Good evening, minions, and welcome to the next session, One Shot series with me, Shreyas. And like the title suggests, we are going to talk about waves today. And the moment I tell you waves, what's the first thing that comes to your mind? I'm pretty sure most of you would have imagined sea waves, all right? And some of you probably could have visualized maybe an earthquake or maybe sound waves or maybe light waves. So what's exactly a wave? That's what we're going to talk about in the start, and then we'll slowly go ahead to different concepts in waves like wave speed, energy, intensity, types of sources and all that. Now look at this amazing formation by these gentlemen out here, and you can see how these people are synchronously going up and down. Do you see that? And it feels like it's a wave pulse. The interesting thing to note over here is that each of them is at their position. They're just going up and down. But a wave, something goes from one side to the other. You can see that. What a synchronization out here. I mean, look at that sync, guys. It's so cool to see that. So that's what we're going to talk about. And we are also going to talk about longitudinal waves. Well, this is called as a key, and you know, you can basically create a pulse, compression and rarefaction, and you can see how that compression or rarefaction goes through that spring. It's really cool. So all this with me, Shreyas, your master teacher for physics at Vedantu. And for all of you who are new, I am the physics master teacher, not just on YouTube, but also on a regular paid platform of Vedantu. And guys, before Vedantu, I have been teaching for a very long time to offline students as well, and many of my students have bagged top India, all India ranks in JEE examination, be it mains or be it advanced. So I am here to spread the joy of learning. I am here to make sure that you enjoy physics with me. And in case you want to know more about me and you want to follow me on my personal Instagram handle, then you can do so. That's it. It's here, Shreyas_Vedantu. You can follow me out there. So welcome all the minions. Hi Science Priya, Priyanka, Vikram, Yalini, Aishwarya, Khiritu just left, I guess. Hi Danush, Manoj, Fida, Saurabh, Palabdata, Anish, Minion Aarti. Hi Nothing Peace. Hi Anish. Hello everyone. Hello. Good evening guys. And before we start, I'm pretty sure all the minions out here who are very true fans, who are our sincere followers, have already smashed that like button out there. Very good. And in case you haven't, please do it now. And if you're new to this channel, guys, first of all, hit that subscribe button. It's free. Yes, it's free, of course, so that you can get all the important updates for boards, for JEE, for all other competitive exams. Hello, welcome. Hello. So, tentative date of starting class 12th syllabus for the next year, Anish, probably around April. All right, probably around April. All right. Very good. Palablata, Anish, very good. And this week is going to be very heavy. Many of you minions have asked me, sir, can you complete the syllabus? Yes, I have listened to you, and reading all your comments and all your suggestions, I have decided that next week I am going to work even more harder for you. I am going to take double the effort, even though it is going to cost me a lot of energy. It's okay. So what I have decided, guys, is, you know, waves will be completed. Look at that. Waves, transverse, longitudinal. Then tomorrow, electromagnetic and light waves. And Wednesday, we're going to do Doppler effect, standing waves, beats. And then on Thursday, Young's double slit experiment and interference of light related problems. So you can see in these 4 lectures, all the concepts of 11th and 12th related to waves will be completed. Some of them are also marathon heavyweight sessions. Then same day, Thursday, remember this is at 10 o'clock. Usually our lectures are at 7 o'clock. These lectures are at 7 o'clock. At 10 o'clock, I'm going to start with modern physics, photons, photoelectric effect. Then on Friday night, understand, Friday night, it's going to be atomic structure and X-rays, and on Saturday, nuclear physics. So that completes most of the parts of modern physics. The only thing which is remaining is semiconductors. That would be done on Monday next week. Keep that in mind. And mock test number 2 on Friday at 7 o'clock. Keep that also in mind. and Sunday is a very special Valentine's Day session. All right. So I hope looking at this timetable, you feel like working harder because I'm going to put in so much of effort for you. That same effort should also be reciprocated back from you guys as well, so that I work even harder. Hello Mustafa, hello Shreya, welcome. Hi Princey, welcome. Yes, so I'm pretty sure many of you are having your eyes on this session now. Valentine's Day special, what is sir going to do? Don't worry, that's a very special session. Let's see what it's going to be all about. Very good Aditya, very good. Yes Saurav, yes I am. All right, so let's begin with our session guys. And now first let me talk about waves. So what is a wave? And what is the difference between a wave motion and particle motion? See, if I throw an object to you or towards you, you will see that particle will carry some energy and it will be received at your end. That particle carries some energy from one point to the other. But look at this simulation out here. These dominoes keep falling. These dominoes retain their original position, but you are seeing the kinetic energy goes from one side to the other side. Do you see that the particles stay there as it is, but it's only the energy which flows from one point to the other. Even though the particles move, their average position is the same. So that is basically a wave motion. So in waves, the particles, if any, stay or maintain their average positions or locations, but it's only the energy which goes from the source to the destination. That's what it would be. Well, Shreya, I don't know. Should it be recorded or should it be live? Because on Valentine's Day, I might be out on a date. So I don't know how I should go live. But I don't know. I have not yet decided whether it should be live or whether it should be recorded. Not yet sure. I don't know what you guys want it to be. Okay, so next up is types of waves. So let's see. Ankit, I don't know, you missed it probably. All right, cool. Let's go ahead. Live. Oh my God. You guys want to be kebab mein haddi on a live date. Is it? I don't know what it should be then. I am also confused what to do. Let's see. So the different types of waves, concentrate back guys. So different types of waves. One is longitudinal wave, second is transverse wave. Now observe this carefully. Look at this particle out here. The wave goes from one side to the other, but look at what the particle is doing. It's going up and down. The motion of a particle is perpendicular to the direction of propagation of the wave. That is called as the transverse wave. And you can see that this particle is doing SHM, a simple harmonic motion kind of a thing. Whereas in longitudinal wave, you can see, look at this red particle out there. That particle is going left and right, and you can see compressions and rarefaction, compressed regions and rarefied or vacuum-like regions going from one side to the other. So the motion of the particle is along the direction of the propagation of the wave. That's longitudinal wave. Yes, Ankit, I did take Erudo course and I hope you were there. And those of you who missed it can also watch the recorded session. And Ankit, I'll also respond to your comments later on. All right? Yes. Thank you, Tejasvi Siv Kumar. Thank you so much. Hello, Bhargav. Good evening. Hello, Vishwajit. Yes. Now, let's talk about the wave equation. Now, I know this, guys. Many of you feel confused whenever you talk about wave equation. But today, after attending this class, believe me, if you attend this class completely, sincerely, you will never face problems in waves. And let's start with a small simulation out here. So what exactly is a wave equation? So let's get Desmos out here and let's make an equation. Okay, so our equation probably can be like y, all right, is equal to maybe something like, I don't know, maybe 2x, all right, 2x whole square. Okay, let's see how that equation looks like. You can see it's nothing but a parabola. You can see that. Can you see that, guys? It's nothing but a parabola. Y is equal to 2x square. Obviously, it's a parabola. Now, let's do some magical thing over here. And what is that magical thing? So let me put over here 2x. Oops, I don't need this. Yeah, 2x minus or plus something. Okay, okay, please go away, dude. Okay, I don't need this. I don't need this. Okay, okay, 1 sec. Yeah, my goodness, it's not budging. Okay, 2x minus something like, I don't know, 4 and then maybe t out here. Okay, cool. Now let's see what exactly happens, and let me add a slider over here, and let me start the value of time with maybe t is equal to maybe 0. Okay, maybe 0, and okay, so from 0 to maybe, I don't know, maybe 10 seconds or something. Okay, 10 seconds out here, and in the steps of, let's say I choose point, oops, let me start using my keyboard, that would be better. 1 sec. Okay, I'll be out of the screen, guys, because you know the screen is acting little bit crazy. So in the steps of point 1. Okay, so now let's see what exactly happens if I play this. Okay, so let's see what happens if I play this 2x minus 4t whole square. Let's play this. Look at that. Oh my god, look at that parabola. It just went outside. In case you didn't notice, let me do this again. Okay, the steps of point 1. Okay, see this again. What happens? See how that parabola goes outside. It's going towards the right side. Do you see that? So you can animate that parabola by writing an equation something like this. I hope this is clear. I hope this is clear. It started running. Now instead of that minus, let me put plus and see what happens. Let me see what happens if I put plus, guys. So let me zoom out again and see what exactly happens. Starting from t is equal to 0, you should guess it, guys, what will happen. I think it will go towards the left side. Yes, it has gone towards the left side. Do you see that? Yes, very interesting. And also see in 1 second how much it has moved. In 1 second, you can see from t is equal to 0 to t is equal to 1 second. I think it has moved 2 units. 2 units. And believe me, this 2 units is 4 divided by 2. Coefficient of time divided by coefficient of x. 4 divided by 2. Do not believe me? No problem. I'll do it again. See, let me make this something else. Let me make this 6. Now what is 6 divided by 2, guys? 6 divided by 2 is 3. So let's see what happens in 1 second. In 1 second, how much has it moved? Check this out. In 1 second, it has moved exactly 3 units. 6 divided by 2. I hope you can see that. I hope you can see that. Very good, minions. Okay, now I can alter the shape. I can alter the shape by choosing some other equation. Maybe let me choose some other crazy equation like y is equal to 10, maybe divided by 10 divided by, let's say, I don't know, something like 4, or maybe 3 plus, I don't know, something like 3 plus 7x minus 2t and maybe whole square or something. I don't know, something like that. Okay, I hope this is clear. Okay, now 1 second, let me make this as capital T. 1 sec, capital T. Okay, now it looks fine. Okay, now let's see what exactly happens when I try to play this simulation. First of all, see where the wave is. Okay, this is too large. Let me make it a little bit smaller. Okay, you can see that there is a beautiful pulse over here. You can see there is a beautiful pulse over here, and let me play this and see what happens. See what happens. Look at that, that pulse starts moving towards the right side. Do you see this is also a wave equation? The pulse start moving towards the right side. And then think about it, what will happen if instead of minus, if I make it plus? If I make it plus, then obviously that pulse should start moving towards the left side. I hope you can see that. Similarly, I can also make some other equation like y is equal to maybe 3 sine of, I don't know, 2 pi x plus, I don't know, maybe 6 pi t. Okay, look at that. I hope you can see that green colored wave. Okay, you can see that green colored wave out there. If it is too big, let me make it a little bit smaller. Okay, or something like this, 2 maybe, yeah, 2. Okay, I hope now the wave is very obvious. Now let's see how does the wave move. It's a sine equation. Let's play this. Oh, it's going too fast. It's going too fast. Okay, let me reduce the steps. Let me reduce the steps to 0.01 and let me make it go till 2 pi. Okay, maybe pi divided by, I don't know, 20 or something. Okay, so in the steps of pi by 20. Oops, this is also going very fast, guys. Hold on. Maybe pi by 100. Probably this will be better. I don't know. Let's see. Yeah, now you can see it. See how the wave is going towards the left side. Can you see that? The wave is going towards the left side because there is a plus sign here. You can see the amplitude of the wave is 2 units because there is a 2 over here. And guys, I can change this plus to minus and see the wave will start going towards the right side. Do you see that? I can reduce the speed by making this 6 pi as 4 pi. Now it will go slowly because 4 divided by 2 is 2. So it will go at 2 meters per second. Wow. I hope this is clear. So basically, guys, like you can see, any wave can be generated by making equations like this. By making equations like this, where you have something x plus something time. It could be any function. It could be quadratic, it could be inverse of quadratic, it could be sine or something like that. And the moment you make something x plus something time, you will see it will represent a wave equation, and the shape of the wave depends on how you write that function. You just saw that. You just saw that. You just saw that. So all the waves can be put like this, all right, and the shape of that wave depends on, you know, how that function is. You can see that. That's how it is. All the waves out here. I hope this is very, very clear. Okay, so let me stop this simulation out here. All right. And let's go back to the slides. Amazing, amazing, amazing. Now, Gem gamers, you can study work power energy in the playlist. It is there. And Ankit, yes, please don't disturb the class. Ankit, focus on the class. Every time I've seen that you're talking about something else, please, like I have told, I have answered all your doubts. So maintain that. Make sure that you post all your doubts after the session. So make sure that you post it in the comments. I'll definitely take a look at it. Yes, Gem, all those work power energy sessions are already there in the playlist. So check out all our playlists. It is there. You can study it from scratch. So here is the final conclusion. The final conclusion is any wave equation will look something like this. Some function, I don't know, of something into x plus or minus something into time. That's how it looks like. And remember this, the wave speed by just looking at the equation will be the coefficient of time. What is the coefficient of time? B upon coefficient of x term. What is it? A. So this is nothing but your wave speed. Next up, how will the plus and minus affect the things? If it is plus, then understand it is going towards negative x axis. The wave is going towards negative x. And if it is minus, then it is going towards positive x axis. Keep this in mind. Okay, this is your next conclusion out here that you should remember. And lastly, also remember that the function, all right, that function decides the shape and size of the wave. It decides the shape and size of that wave. Keep this in mind. So if you remember these 3 pointers, you will be able to solve so many problems. No problem, Ankit. Yes, focus on the session. Don't worry, Ankit. I'll solve all your doubts. Don't worry, bacha. Very good, Mohammed. Join in. Okay, now Bhargav, PSI is a unit of pressure but not relevant over here, so don't worry about it. Okay, so having said that, let's move ahead. Now let's talk more about transverse wave. Now in a transverse wave, like I was telling you, each particle goes up and down, all right, and there is something called as the wavelength. So what is the wavelength? Wavelength is the distance from one crest to next crest, or from one trough to next trough, or from one point to another point which is similar in nature. So if there are 2 points identical in nature, just take the distance between them, that will be nothing but the wavelength. Keep this in mind. So there are some important things now we are going to learn. Okay, so that is number 1. Keep all these pointers in mind, guys. Very, very important. Each particle, okay, each particle will go up and down. It will go up and down. In fact, it is going to perform something like a SHM. That SHM, which each particle will perform, will have angular frequency omega. This is angular frequency, guys. Remember the units were radians per second. This is 2 pi into f, where this f is nothing but just the frequency of the wave. Keep this in mind. The frequency of the wave, which is expressed in hertz, that is omega. Omega is 2 pi f. That's number 1 quantity. Second quantity which you should keep in mind is if wavelength is given by lambda, lambda is in meters, okay, then you have a new term called as angular wave number. It's a new quantity which we are defining, k, which is 2 pi divided by lambda. 2 pi divided by lambda. Now the unit for this will be radian per meter. Now what does it exactly tell you? Let me show that. Now if you focus your attention on a point here, okay, the trough and the next trough, don't you think that both these points will be simultaneously going up and down? Correct, guys? Both these points will be simultaneously going up and down. So think about it. Between these 2 points, what is the phase difference? What is the phase difference? The phase difference is nothing but 2 pi, guys. The phase difference between them is 2 pi radian. Why is it 2 pi radian? Think about it. SHMs, 2 SHMs going up and down. All right. So understand, when I go from one point to the next point, there is a small phase difference because these 2 things are not going up and down simultaneously. There is maybe a phase difference of 5-10 degrees. This particle and this particle, there is some more phase difference. This particle and this particle, there is probably opposite. They are out of phase. If one is going here, this one is going here. So 180 or pi radians of phase difference. So as you keep going to the next and next particle, the phase difference keeps changing, and the first time you will find a particle which is doing exactly the same thing as this particle will be, in sync, and that's why I'm saying the phase difference is 2 pi radians. Basically, you have come back to an identical point. I hope this is clear. Okay, so that's the meaning of the phase difference between 2 points. Now, as I go ahead, the phase difference keeps increasing. If I reach here, the phase difference between this and that point, between this and this point, will be 2 pi plus 2 pi, which will be 4 pi radians. It will be 4 pi radians. Mohammed, just watch it in little bit lower resolution, probably that will help. Correct. Hence, if I have to tell you, there are some 2 random points, maybe this point here and this point here, and I tell you the difference between them is delta x. Okay, the difference between them is delta x. Then the phase difference between these 2 points, any 2 points separated by delta x, will be 2 pi radians is the phase for one wavelength. So look at that, this is one complete wavelength. So for one wavelength, the phase difference is 2 pi. So for these 2 points, the phase difference will be 2 pi by lambda into delta x. This is unitary method. For one wavelength, it is 2 pi. So for delta x, how much is the phase difference? Correcto? Understood? Clearo, guys? Clearo, this is it clear? I hope this is clear. Very good. All right. Now, probably everything makes sense over here. What is K? K is how many radians per meter? That's it. How many radians per meter? So 2 pi radians is per one wavelength. So that is the value of K. 2 pi radians per wavelength. That is the meaning of angular wave number. How many radians are you getting per meter? That's all it is. I hope this is clear. So 2 pi by lambda, this is basically k, that is a constant. Is that okay? Great. So remember these formulas, okay? So I have highlighted them and you should know who is what, okay? So all these things are important. This, very, very important slide out here for all of you. Excellent, guys. That's very good. Now, when you have a sine wave which is generated and it is going, just like I showed it to you in my simulation just few minutes back, and if you have joined in late, don't worry, just rewind back and you can watch it, all right? In a live session also you can rewind back and you can catch up to whatever we are doing now. So there is something called as the amplitude. This is A, and of course you will have the wavelength out here. So from here to here, this one is nothing but your wavelength, and the wave equation will look like this. Y is equal to amplitude times sine or cos, doesn't matter, okay? And then you will have kx plus or minus omega t plus phi. This is your general wave equation. Keep this in mind for a sine wave. If it is not a sine wave, then it could be something else. Maybe instead of sine or cos, you will have a quadratic equation, or maybe logarithmic or exponential. Depends on how that wave is. So if it is a sine looking wave, then it will be something sine or cos kx plus minus omega t. Don't you remember the coefficient of x is replaced over here? Instead of a, you are putting k, and coefficient of time, instead of b, I am writing it as omega. So guys, what are all these terms? A is basically your amplitude of that wave. How tall or how high that wave is. If this number is more, the wave will be stretched out more. Understand? This k, like I told you, it is 2 pi divided by wavelength, and this omega, like I told you before, is 2 pi f. All right. What is this phi? This phi is your phase constant. Phase constant. Now let me show this to you so that you get some idea out of this. Okay, once again. Okay, I'll have to probably erase this. So I'll just erase this after some time. First, let me get to all the terms and then I'll show you all the simulations. Now, remember, I just told you some time back, wave speed is coefficient of time term divided by coefficient of x term, coefficient of time, b by a. So here b is omega, a is k. And what is omega? 2 pi f. And what is k? 2 pi by lambda. 2 pi goes and it will become lambda f. Isn't this your standard wave equation? Wave velocity equation. V is f lambda. You have studied this in chemistry's atomic structure. So omega by k or lambda f, one and the same thing. Yes, correcto. Very good Priyanka Princy. Excelente. Very good Fida. Very good. Now, if this much is clear, let me show this to you. What exactly are we talking about? Let's come back to this graph. Hi Anish. All right. So let's come back to this graph. Now observe what happens when I change each of these terms. Look at this. Right now, if you notice, the amplitude of the wave is 2. Now instead of this 2 over here if I write 1.5, you can see the amplitude will reduce. The amplitude will reduce to 1.5. You can see that. All right. Similarly, I can make it something else, maybe just 0.8 or something. Then you will see the amplitude reduces even further. So the amplitude is decided. You can see the amplitude is 0.8. That amplitude depends on this number over here. Okay, this number over here. Now, instead of 2 pi, if I make another number, remember what is the coefficient of x called? K. If I change k, who will be affected? Think about it. Lambda. So lambda will get affected. Observe that. Oh, if I make it 1000, it will go out of the screen. You can try it out later on maybe. So let's change this. If I make it 6 or something, see how the wavelength of the wave has changed. Can you see that? The wavelength has changed. If I again make it, let's say just 1 pi, again you can see the wavelength has changed. So more this number, lesser the wavelength. Why? K is 2 pi by lambda. More the k, less the lambda. less the k, more the lambda. Understand? It goes inversely. So if it is less k, bigger wavelength. If I make more k, less wavelength. Can you see that? I hope this is clear. I hope this is clear, guys. So this is something which you should remember. Now you should never forget all this. And lastly, okay, one second. Lastly, this one. Remember y was, let's say for example, a sine, omega t plus minus kx, doesn't matter which one you write first. Then very important stuff, guys. If you concentrate on any point over here, this point will be going up or down. There will be something called as velocity of that particle, and that particle will have some y coordinate. All right, it will have some y coordinate. So the velocity of any particle, remember this, is derivative of y with respect to time. Differentiation, rate of change of y with respect to time. How is y coordinate changing? Small displacement upon small time. That is how it is. And when you differentiate this, guys, when you differentiate this, isn't it obvious? Sine's derivative will be cos. So it will be cos of omega t plus minus kx. And what will happen? Because you are differentiating with time, the coefficient of time will come outside and it will become a omega. This looks to me like a SHM kind of formula. So from sine you have come to cos. This a omega, like you can see over here, all right, this a omega will be maximum speed of the particle, max speed of particle. That's what it would be. I hope this is clear. So Ankit, this is just differentiation. Remember, this equation was just the wave equation. This was just the wave equation, a sine omega t plus minus kx. Differentiate this derivative. Why derivative? Because velocity at any instant is derivative of displacement. So derivative will give you, sine's derivative is cos, and whenever you have some multiplying factor, it comes outside. That's the rule of derivatives. Okay, cool. Great. I hope that's clear. Cool. Acha. Now longitudinal wave equation. Now this is little bit crazy. Now pay attention carefully. Okay, guys, you are going to learn everything today regarding transverse and longitudinal waves equation, wave speed, and also intensity or energy. So that's what we are focusing on. Remember, Doppler effect, etc. will be taught separately. There is a separate lecture for interference and Doppler effect and beats and all that. I want you guys to first learn wave speed equation, etc. today. So pay attention. In longitudinal waves, notice how there are some regions which are compressed. Notice how some regions are elongated. Compressions, rarefactions, compressions, rarefactions. And see how these compressions and rarefactions are traveling. But look at the particles. I have shown some two dots. Those two dots just go back and forth. You can see that. Those two dots just go back and forth. You can see that very, very clearly. Now, understand, if I have to write the equation of any particle, all right, equation of any particle, each particle is going back and forth. Each particle is going back and forth like this. So there is some mean position and the particle is going back and forth. So there is some amplitude. This SM over here is called as the displacement, okay, displacement amplitude. Very important. How much does any particle move from its mean position? That is called as the displacement amplitude or just displacement amplitude. Keep this in mind. Very important term. And any particle's displacement amplitude will give you, in fact, the motion of that particle. Just like SHM, guys, or just like a wave equation, nothing else. So just like in transverse wave, each particle used to go up and down like this, correct? And you used to have y is equal to a sine kx plus minus omega t. Now instead of a, what will you have? And instead of y, what will you have? Instead of y, you will have s, and instead of a, you will have sm, and you will have sine of kx plus or minus omega t plus phi. Keep this in mind. That's the only change that will be there. So sm is your displacement amplitude. What is s then? S is the displacement. S is the displacement from the mean position. Very important. S is the displacement at some instant from the mean position, because the particle is continuously going to go back and forth. Very good Science Priya, very good Yalini, very good Princey, excellent. Now notice one more thing, and that is the pressure. If you look at this graph, okay, if you look at this graph of pressure versus distance, at every point if I check what is the pressure, here, etc., then this graph of pressure versus displacement is going to look something like this. See, some places there is high pressure, low pressure, high pressure, low pressure. So it's going to go up, down, like this. Yes, it's going to go up and down like this. So let's see how that graph exactly looks like. I hope you have noted this term down. I'll just erase this. So another important thing which we are doing now is, if I draw a graph of, pressure versus distance, that graph is going to go up, down like this. Now, if I draw, very important now this is, if I draw a line like this, it looks like a sine curve to me, as if it has been shifted from here to here. Why is it so? Because I'll tell you, this average value of the pressure is actually the atmospheric pressure. Yes, this is your average atmospheric pressure of that particular sound wave. Very important. This is the average pressure. Some places there is more than usual pressure, some places there is less than the usual pressure. Wherever there is less pressure, I call it rarefaction. Wherever there is more pressure, I call it compression. Keep that in mind. I hope this is clear. Now, this one over here, this is called as PM, and this PM stands for, not Prime Minister, it is called as pressure's amplitude, pressure amplitude. This is called as a pressure amplitude. Very important. How much does the pressure vary? That's what it is. And like you can see, alright, guys, the excess pressure, very important, excess pressure at any point, okay, is going to be, think about it, PM, sine or cosine doesn't matter, okay, kx plus minus omega t. Okay, that's how it will look like. So to be PM sine function or cosine function, depends, whatever you want to take, and this PM is basically the amplitude of it. It's nothing but a sine equation, that's it. The excess pressure, what do you mean by excess pressure? Excess pressure is basically at any point, what is the excess pressure above the normal? Understand? That's it. Yes, that's it. If I ask you what is the actual pressure, it will be excess pressure plus the atmospheric pressure. That will be the total actual pressure at that point. And we are generally not interested in the actual pressure. We are generally interested in the excess pressure. How much is the variation in the pressure? Keep this in mind. Yes, keep this in mind. So this is PM sine kx plus minus omega t. Now, you might be wondering, is there any relationship between this displacement and the pressure variations here? Yes, there is a relationship between both of them. And remember this formula, which is PM is equal to BKSM. This is very, very important formula again. So coming back, what is PM? Pressure, amplitude, which is max variation of pressure. Max variation of the pressure is called as the pressure amplitude. What is B? Bulk modulus. Yes, it's the bulk modulus. Keep this in mind. And what is K? I just told you, angular wave number. It's angular wave number, and this is displacement amplitude. Keep this in mind. Displacement amplitude. PM is BKSM. PM is BKSM. PM is pressure's maximum variation. SM is maximum variation of displacement. PM is BKSM. Keep this in mind. That's it. Now, see, that is the hard part about waves. There are a lot of stuff to remember, but believe me, the questions are so easy, and you will see that now. You will see that now in some time. Yes, get ready. So, note it down. I hope you have noted it down. All right. Cool. Last few formulas, and then we can start for problems. Shall we go ahead, guys? I hope you are not going to get too much confused. I know it's a lot to take in. It happens, believe me, but just have faith. Once you look at the questions, you will be like, what the hell, sir? I mean, really, are the questions really that simple from waves? Yes. So why do people score less in physics at times? Because they just give up on certain topics. Example, waves. But they don't realize actually waves is so scoring once you understand the formulas and the concept. That's all. Let's get going. Yes. Wave speed. If you generate a wave on a string, the wave travels with certain speed, and that speed of a wave depends on, okay, let me tell you, yes, that wave speed depends on, number one, I'll tell you, first is obviously the tension. So whatever is the tension in that string, that tension decides the wave speed. And next thing is per meter. So let's say this is unit length. What is the mass? All right, what is the mass per unit length? So it depends on these two quantities, and the wave speed is given by root of tension by mu, where this mu is mass per unit length. So the unit is kg per meter. Keep this in mind, kg per meter. And sometimes what happens is, guys, they don't give you the value of mu, but they give you the value of density of that string. And when that happens, keep this in mind, mu is density multiplied by area of cross section. Yes, that area of cross section which is there, that area of cross section, that will give you mu. This is also very important, and it's not that difficult to realize this, that you know mu is nothing but kgs per meter, density is nothing but kg per meter cube, and area is meter square. So the mass per volume into area gives you mass per unit length. Keep this in mind. Yes, it depends on the material. Yes, it will depend on the material, like you can see. Correcto. Yes. Keep all these formulas in mind. It will help you guys. Cool. Let's get going ahead. Next up. Okay. Cool. Let's get going to the next and the last part of speed and waves, and then we'll go to problems and energies and stuff like that. Remember, sound requires medium. In space, sound cannot travel because there is no medium, but sound can propagate through gases, through liquids, as well as solids. And there are three formulas, but identical formulas for sound. And let's see what they are. When sound travels, this is longitudinal wave. Remember, the previous one was transverse wave. So we are seeing both chapters together. So guys, speed of sound in solids, speed of sound in solid is root of Young's modulus by density. Keep this in mind. Root of Young's modulus by density. Y is Young's modulus. Young's modulus. Keep this in mind. And rho is obviously density. I'm writing it over here. Then this is in solid, but the speed of sound in liquids slightly different. Instead of Young's modulus, put bulk modulus and divided by density. Same thing, but slightly different. So this is density again, and this B is obviously bulk modulus. Bulk modulus. Last thing, but not the least, very important now, speed of sound in air, guys. Yes, speed of sound in gases or in air, ideal gas, is root of gamma P by rho, which is also using gas equation because PM is rho RT. Using PM is equal to rho RT, you will get gamma RT. Okay, if this is not clear, gamma, this is gamma, guys, gamma RT by molecular weight. This is also very important formula. This is for gas, solids and liquids. Done. So remember, gamma is that ratio of Cp by Cv. P is pressure, obviously, and over here T is temperature, R is your gas constant, M is your molecular weight. Whichever formula you feel like using. Yes. Thank you, Princy. No problem, Naveen. Just join in, and you can do one more thing, Naveen. It's better you just rewind back a little bit, catch up to wherever we are within next 10-15 minutes. Okay? You can do that also. Okay. Cool. Let's go to some problems now. Okay? And I will give you guys some time to catch up also, in case you know what I'm going to do next. So guys, for all the new timers, especially this is, for especially all the 12th standard students and the dropper students, this is very important because all the regular students already know about it, and somebody or some of you might have already enrolled into this. We have, a dedicated plan to cover up all your backlogs and to make sure that all your 11th and 12th standard syllabus gets revised for your next attempt of JEE, be it second or be it third. Now, the thing is, we need that plan because you need somebody to always push you. Also, you need somebody to guide you and tell you, this has to be done and that has to be done. Don't do this, do that. And plus, you need to see other students as well studying under you so that, you get that sense of competition. That's very important. And also, what is very important, that you realize through mock tests what are your mistakes and improve upon them. So, if you're facing any of these problems, like how to do all these subjects, how to revise all the portions, etc., don't worry. We have a crash course dedicated for all of you, especially the 12th and the dropper students. All the syllabus will be completed in a very systematic, scheduled manner by the topmost teachers of the country. That's very important. The thing with offline is that you get some random batch and maybe you cannot choose teachers, and sometimes you are not getting the best experienced faculties. But at Vedantu, the advantage is, doesn't matter whether you are from Andaman, whether you are from Kashmir, whether you are from, Maharashtra or from Odisha, always you get the best faculties because the same faculty will be teaching all the students, number one. Number two, you also get doubt solving through two-teacher model in the class. So one teacher is teaching, other teacher is solving your doubts. And number three, after the class also you get doubt solving facilities through those teachers out there. So from morning till night, these teachers are going to dedicate themselves for solving all your doubts. That's the best part. And remember one thing, that mock tests will be conducted regularly. Almost every Sunday there is going to be a mock test, and there are going to be 20 mock tests with discussions. Yes, with discussions. And also there are going to be handwritten notes given to all of you. All this at a very affordable price of 8,000 rupees. That is after a discount. Usual price is 10,000, guys. So after the discount, it comes to 8,000 rupees, and you can get that discount. If you want to save money, then you can use SHCC coupon code to avail that offer. So there is a link in the description box. Go check it out. Open up all the page. Remember, you can enroll even now, because the batches start every Monday. In fact, there is a batch which has just started today. So don't wait. Enroll now. Do not hesitate to take help. Remember, what matters in the end is whether you have qualified or you have not qualified. And you definitely don't want to be a person who has not qualified or who has got a lesser rank for some weird reason. So make it a point that if you have been given an opportunity, if you have been given a platform, make use of that platform, because that's what is going to help you. Okay, so let's get going. I hope you are going to check it out. Let's get going to the problems now. Here is the first question up on your screen. Here it is. Yes, I used to watch Formula 1, Mr. Best, but these days I hardly have time, but I love cars. Okay. Very good, Abhijit. Glad. Love you too, Abhijit. Okay. Let's see this, how to solve this question. The displacement of a particle in a medium is 10 to the power minus 6 sine 100t plus 20x plus pi by 4, where t is in seconds, x is in meters. What is the speed of the wave? Come on, guys. What is the answer? Priyanka says B. I don't know. Come on. Let's see. How many of you are getting this answer? So, guys, I just told you how to solve these kind of questions. Remember, y is some function of ax plus minus bt. The wave speed is given by b by a. So over here also, velocity will be, who is b? B is 100. Yes, coefficient of time. By coefficient of x, what is that? 20. So guys, what is it going to give you? 5 meters per second. Correct, that's the answer. And if you're wondering where will it travel, look at this sign. What is it? Plus. So if it is plus, it is going to go in the negative x axis. That's how the equation will look like. I hope that's clear. Very good. All the minions have answered B. Excellent, guys. That's the correct answer. Okay, that's the correct answer. Like you can see, 5 meters per second. Cool. Let's go to the next question. Let's see how many of you get this. All the minions out here. The speed of sound in air is 300 meters per second. If the air pressure doubles, then the temperature, if it remains the same, what would be the speed of sound now be? Come on, think about it. Come on. Think about it. Come on, guys. Hello, Deepak. Welcome to this channel. Join in. Come on. Let's see how many of you get it. If the air pressure doubles, then the temperature of that medium will become. Come on, think about it. Hi, Hatim Ali. Join in. Welcome to this channel. So we are doing sound waves, transverse waves, everyone, and we have come to the questions part. And if you feel that you have missed the theory, you can always rewind back a little bit and watch. Even during the live session, you can watch the previous part. And don't worry, after the session ends, the entire video will be available to you, all of you. Okay, see, well, let me tell you what. See, guys, what was the speed of sound? The speed of sound was given by this formula. V is root gamma p by rho. In the question, it says the pressure becomes double. So most of you might think pressure becomes double, so root of pressure will become root 2 times. But if pressure doubles, what happens to the density? Think about it. What about density? Do you know what happens to density? No. So how can you use this formula? So better do not use this formula. Instead use root of gamma RT by M. Now if pressure doubles, neither gamma will change nor R will change. They are constants, right? And molecular weight will also not change. What happens to temperature? Is it given? Well, it's clearly given. Temperature is the same. So if temperature is same, what will happen to the speed? The speed will also be same, and hence the speed should remain 300 meters per second. So the answer is 300 meters per second. It's a trick question and many of you might fall for this. I hope this is clear. So this question tells you when to use which formula. Be careful, read between the lines, think beyond what is there in the question or formula. Yes. Yalini, don't worry. It happens. These are all tricky questions. Okay, so the answer is D. Yes, Naveen. Yes, welcome, join in. Now let's go to the next question. Don't get scared by looking at the length of the question. This was asked last year in JEE Mains. Yes, this can be asked in NEET or BITSAT also. You never know, because it's not so difficult. Trust me. Now, displacement is proportional to pressure difference, and displacement also depends on density and frequency. Okay, if change in pressure is this much, rho is this much, and frequency is this much, then what is the displacement? Very good question. Let's see how to do this. यार ये डॉक्टर आइंस्टीन को निकालो यहां से, तो पहले तो wait, let me just remove this user from this channel. Okay, so minions, you should be reporting such random fake people out here from our channel. Yeah, yes, cool. So now let's see how to solve this problem. Now here is what I will do. Remember, I just told you what is the difference between pressure and what is the relationship between pressure and displacement just some time back, and that was, let's go back here, it was PM is equal to BKSM. I just told you some time back, isn't it? PM was BKSM. Now, is bulk modulus given? No. What else is given? Pressure is given, density is given, frequency is given. So I need to somehow get density and frequency. Let's see how do we do that. First of all, remember, okay, velocity was omega by k. Remember, velocity was omega by k. So can I say k is nothing but omega divided by v? Okay, that's one thing. And next thing, what I can do is, velocity was also bulk modulus by density. That was the formula. So rearranging it, I'll get B is equal to rho v square. So do both these substitutions here. Why? Because I want it in the given terms. I want the given terms over here. So here is what we are going to get. PM is equal to, instead of B, I will put rho v square. Instead of K, I will put omega divided by V. And instead of SM, I'll just put SM, obviously. Now V gets cancelled, and therefore I'll get SM is equal to, okay, SM is equal to, what am I going to get? PM, okay, divided by, density comes below, velocity comes below, and omega also comes below. That's what I'll get. Solving it further, I'll get SM is equal to PM divided by rho v omega. Omega can be written as 2 pi f. So omega can be written as 2 pi f, and what remains is density into velocity. Now, this is maximum displacement. This is maximum pressure. So can I say displacement is proportional to excess pressure divided by, alright, some constants. 2 pi is also some constant. Frequency into density into velocity. Frequency into density into velocity. Now everything is known. Look at that. Del P. Del P is how much? It is given as 10 pascals. Velocity is how much? Well, that's given as 300, guys. Density is how much? This is given to be 1. Frequency is how much? It is given to be 10 to the power 3. And constant of proportionality is 1. That's the best part. So what is done? It's all about using formulas. See, all formulas are used. Velocity, PM is VKSM. That's all they asked, guys. Formula based question this is. Pure formula based. And that's it over here. Just solve this. And what are you going to get? This was 10. This was, okay, 300. All right. Just check this out, guys. If this makes sense. Correct. And what can I do? I can write 1 by 30. Yes, this will become 1 by 30 into 10 to the power minus 3 meters. I think the options were in millimeters. So this will become 1 by 30 millimeters. But this can be further simplified, guys, because I want to get it in the form of the options. So this will be nothing but 0.033 millimeters, which will be nothing but 33 by 100 millimeters, approximately 33 by millimeters, 100 millimeters. So that's the answer, guys. So I hope this is clear. Almost. Oh, 33, nahi? My bad, guys. 3, okay. Sorry, 3 millimeters. Okay, so that's 3.33. Yes. So by mistake, I put 33, guys, over there. So just ignore that. It was supposed to be 3.3 divided by 100. My bad. It was 3.3 divided by 100 millimeters. So which is approximately 3 millimeters by 100. Yes, correcto. Very good. Very nice, Ankit. Very nice. In fact, Ankit, I would say, in fact, other minions also, keep making notes and keep adding all the notes into single notebook. Remember one thing. When the final examination comes, you should be revising from one single notebook for one subject. Physics from one notebook, chemistry from one notebook, maths from one notebook. All the formulas, all definitions, all concepts, all things in one book. Yes, that's very important. Yes, very good. Some of the minions have already done this. Next question up here. Okay, let's do this. The pressure is given by this equation for a sound wave, and atmospheric pressure is 0 degrees Celsius, and other day the temperature is T. The speed of sound on that day when the temperature is T is 336. So what is the approximate value? Okay, approximate value of T. Let's do this. Okay, let's do this. Now, first of all, initially at 0 degrees Celsius, what is the speed of sound? Let's find it out. V0. Here it is given. The equation of the wave is given to us. So remember, speed is coefficient of time divided by coefficient of x. So what is the coefficient of time? 1000 divided by coefficient of x, 3. That many meters per second. Keep this aside. When the temperature is T degrees Celsius, then okay, the speed is given to be how much? 336 meters per second. Now, here is the thing. Velocity is root gamma RT by m. Therefore, isn't velocity proportional to root of t? If velocity is proportional to root of t, my dear minions, then think about it. Can I not say Vt by V0 will be temperature at T upon temperature at 0 root of temperature at T upon root of temperature at 0 degrees Celsius. But keep in mind, do not put answers in Celsius, they are always in Kelvin. So a lot of people put 0 here and wonder what is wrong. No, it's always in Kelvin. So therefore, Vt is how much? 336 divided by V0 is how much? 1000 divided by 3 root of temperature in Kelvin upon temperature in Celsius. Okay, now 336 into 3, guys. 336 into 3, think about it. How much will it become? 336 into, come on guys, tell me, how much will it become? Come on, 336 into 3. 336 multiplied by 3 whole square, let's square both sides, divided by 1000 is equal to T by 273, and therefore T will be equal to 336 into 3, guys. Yes, very good. 1008. Excellent, guys. 1008 divided by what is this? 1000 whole square multiplied by 273. Now when you solve this, it will be slightly more than 273, slightly more. It comes close to 277 Kelvin, which is approximately 4 degrees Celsius. That's the answer. Purely formula based question. You can see that. Purely formula based. Interesting. Let's go ahead. I hope now you are gaining some confidence that actually speed of sound, velocity, wave equation, pressure wave, etc. are actually simple questions only. The questions asked in waves are actually simple. It just looks difficult in the beginning. Yes, let's get going to the next question. I'm making you practice a lot of questions, and especially through PYQs also. This is 2013 question. Let's see how to solve this. In a transverse wave, distance between crest and a neighboring trough at some instant is 4 centimeters. And the distance between a crest and a trough at the same place is 1 centimeter. Okay. The next crest appears at the same place after a time interval of 0.4 seconds. The maximum speed of vibration of particles in the medium is, looks crazy, but trust me, it is not. Let's see what and all is given to us, and trust me, you're going to find it very, very simple, guys. So, first information, the distance between, okay, the distance between a crest and a neighboring trough at same instant, that means this to this, from a crest to a neighboring trough, how much is it? 4 centimeters. By the way, from here to here is one wavelength, isn't that? From here to here is one wavelength. So, can I not say lambda by 2 is actually 4 centimeters? Half the wavelength is 4. So, wavelength is actually 8 centimeters. Fine. That is what the first piece of information is. Next up, the distance between a crest and a trough at the same place. Now, I'll be like, how can it be at the same place? See, this wave is going to move. When this wave moves, the crest will be here and next a trough will come. For example, at this place, the crest is here. After some time, the trough will come. So this distance is what has been given. So they have told this distance is how much? 1 centimeter. Oh, but this is A, correct? And this is also A. So basically, 2A is given to be 1 centimeter. That means A is equal to 0.5 centimeter, guys. Isn't that right? Last piece of information. The next crest appears at the same place after a time interval of 0.4 seconds. That means if you wait at a place, let's say here, the next crest comes after 0.4 seconds. That means that is the time period of that wave. Yes, the time period of that wave is 0.4 seconds. That means the frequency is 1 divided by 0.4 in hertz. All right, 1 divided by 0.4 hertz. That's what you should understand, which is 4 by 10 or 10 by 4, which is nothing but 5 by 2 hertz. That's what it is. Now that we know all the information out here, it's just about solving it. What is the max speed of a particle which is vibrating? Didn't I just tell you some time back, each particle performs SHM? Each particle is performing SHM. And what is the max speed of SHM? What is the V max of SHM? Isn't it A omega? Isn't it A omega, guys? That's it. Use that. What is the max speed? V max will be amplitude. How much is the amplitude? 0.5. 0.5 multiplied by omega. Oh, I know frequency. So omega will be 2 pi multiplied by F. F is how much? 5 divided by 2. 2 goes. 0.5 into 5, 2.5. So this will become 2.5 pi, which is 5 by 2 pi centimeters per second, because everything was in centimeters. That's the answer. I hope this is clear. That's how you need to solve the problem systematically. See how I approach the problem. Isn't it simple? I saw what is given, I wrote it down nicely, neatly, visualized it, used my formulas. So I should have that memory of formulas. And then I saw what is asked and manipulated it to get the final answer. That's it. Also check the units. That's all. Cool. I'm pretty sure after this you are going to get some confidence. Let's go to energy of a wave. Very, very important formulas. So guys, I'm going to conduct the lecture for more 15 minutes or so. Alright, so bear with me because I want to complete energy and intensity also today. So that's why it's a one-shot series lecture. Energy of a wave. Whenever wave moves, what does it do? It takes energy from one point to the other point. So basically, every wave carries energy. The rate at which it carries energy is called as the power of wave. Now, the power of a wave is basically, the energy flowing per unit time. Now the problem is I never want, usually I don't want what is the energy flowing per unit time. I want the average flow of energy. So basically we are talking about averages over here. So average flow of energy, which is the average power. So let's see what's the formula. The formula is half mu v a square omega square. Keep this in mind. Half mu v a square omega square, all standard terms. Mu is basically kg per meter, mass per unit length. This v is speed of the wave, standard formula. This a is amplitude, and this omega standard, which is 2 pi f. All standard things. Half mu v a square omega square is the average rate at which energy flows. This is the average flow of energy. Remember this, for a wave on a string. This is for a string. When a wave flows on a string, that is the energy. Yes, Surur, I'll be doing communication systems also, don't worry. But for now, let's complete the compulsory section. All right. First, let's focus on the compulsory section this week, and next week probably we'll do all those other things. Great. Now, intensity of sound. The last slide was for transverse waves. The next slide is for sound or longitudinal waves. Keep this in mind. Now, for longitudinal waves, you are not interested in the power. Usually, you are interested in power per unit area, which is called as intensity. How intense is that energy? More power in less area is more intense sound. That is called as intensity. And usually what happens is, when you move away from a source, that same power gets spreaded, all right, it spreads on a larger area, because of which the concentration of energy reduces, hence the intensity of the sound also reduces. So the sound is fainter. That's why we are more interested in the intensity of the sound. And obviously intensity depends on the amplitude as well. So if a bird is chirping melodiously, the variations of pressure are very small. But if the bird is screaming its lungs out like crazy, it's yelling at, I don't know, someone or some other bird, then the pressure variations will be very large. That's more intense. So remember, intensity is basically average average power per unit area. That means the units will be watts per meter square. And the formula for intensity is similar. Half pressure amplitude square by rho into V. Keep this in mind. Very important formula. PM is your standard. Pressure amplitude. I'm writing this again and again. You will understand why. Because the more you write it, the more it will get into your head. You will never forget what is PM. That's why I'm writing it. And V is velocity of sound, obviously. And rho is density, which is in kg per meter cube usually. So keep this in mind. Half PM square by rho V is the intensity, how intense the sound is. And it is power by area. So if somebody gives you intensity, you can find power by multiplying intensity with area. So intensity into area gives you power which is flowing through that area. Keep this in mind. Yes, angry bird. Now, loudness. Loudness is a logarithmic function of intensity. Keep this in mind. Okay, it's a logarithmic function of intensity, how loud the sound is, and loudness is given by 10 log I divided by I minimum. Okay, and the unit of this, very, very important, is decibel. Yes, the unit is decibels. Keep this in mind. dB. You might have heard this. Now you might be wondering what this I and I minimum are. Well, this I over here, that is your standard intensity. But keep this in mind, this one over here is the smallest intensity that can be heard. That can be heard, and that is usually 10 to the power minus 12 watts per meter square. Keep this in mind. So, to give you an example, for example, let's say the intensity of sound is 10 to the power minus 5 watts per meter square. How much is the loudness? Let's do this calculation. Let's do this calculation. So, loudness will be 10 log intensity of the sound is 10 to the power minus 5. The smallest intensity which can be heard by a human being is so small. It's 10 to the power minus 12. Very, very small, guys. So 10 to the power minus 12. Do this math. It will be 10 log. This 12 will go upstairs. 12 minus 5, guys, is 7. So 10 to the power 7. Now what is 10 log 10 to the power 7? That will be 10 multiplied by 7, which is 70 decibels. That sound is of 70 decibels. I hope this is clear. I hope this is clear. Okay? That's how you calculate intensity and loudness. Keep this in mind. Okay? Cool, guys? Let's go ahead. Let's go ahead. Okay. Now, last thing over here, and that is different types of sources. Point source, cylindrical source, and planar source. Imagine a source which can propagate sound in all the directions, left, right, top, bottom, up and down, everywhere. That means the sound is going everywhere. So you will see the sound is distributed over imaginary spheres, those spheres which are constantly expanding, like the light rays from sun expand in all the directions and they form spherical wavefronts which are constantly expanding. That's an example of point source of sound. Okay, this is called as a point or spherical source of sound. Keep this in mind. This is point or spherical source. It goes in the form of spherical wavefronts everywhere. Next is cylindrical. Cylindrical. In cylindrical source, what happens? The sound, all right, will go like this in all the directions, radially outwards. Radially outwards. It will expand in the form of cylinder. Think of a cylinder like a JBL speaker. Probably you might have seen this. In case you haven't, I'll just show it to you like this, like a speaker like this. All right. This is a cylindrical source of sound. Yes, the sound will go like this, like this, like this, but there is negligible sound which is assumed to be going here or here. I hope that is clear. That's the meaning of a cylindrical source of sound. Planar, it's a flat plane. It's like a flat speaker and the sound is going only forward. It's not spreading anywhere. Ideal source. All right. All these are. So this is nothing but planar source of sound. Now, the important thing to remember is if you are at a distance of r, the intensity is inversely proportional to r square. Keep this in mind. For whom? For point source. Intensity is inversely proportional to r square. But if you are away from a cylindrical source, then the intensity is inversely proportional to just r. Just r. For point source, it is r square. For cylindrical, it is just inversely proportional to r. But for a planar source, that's very interesting. The intensity will be constant because no matter how far you go, the sound is concentrated on the same region. So intensity is constant. Keep this in mind. I hope this is clear. By the way, the same principle is also applicable for light. All three different sources for light also, it will give the same answer. Cool. I hope you have noted it down. Let's start with some questions. Last few questions for today. Come on, guys. Don't let the josh die out. Come on, minions. Last 2-3 questions for you guys today. If the pressure amplitude of a sound wave is tripled, then by what factor does the intensity of the sound wave change? Come on, minions. Think about it. Think. By what factor does the intensity of the sound increase? Come on minions, is it 3, 6, 9 or root 3? If the pressure amplitude of a sound wave is tripled, the intensity will change by how many times? How much is that factor? Think, use the formula, you will get it. Think about it. C9. All right, most of you probably get that. So guys, intensity was Pm square by 2 rho V. So very simple. If Pm increases 2 times, the square of it will become, 3 times, my bad. If it increases 3 times, the square of it will become 9 times. So intensity will increase 9 times. That's the answer. Excellent, minions. Very good. Excellent. Proud of yourself. Okay, next 2007 question. There is a sound absorber which reduces, attenuates means reduces. Amplitude increases, that is called as amplification. Reducing the sound is attenuation. The sound level by 20 decibel, then the intensity decreases by a factor of how much? 2007 question. Now trust me, this is so simple, but people just made so many mistakes or thought it is very difficult. What the hell is attenuates and etc. Guys, I'll tell you what. Use the formula for loudness. Loudness is 10 log I by I minimum. Isn't that right? Now what is given? The sound gets absorbed and it reduces by 20 decibel. So think about it. L2 minus L1 will be 10 log I2 by I minimum minus 10 log I1 by I minimum. Isn't that right? Loudness 2 minus loudness 1 is 10 log this minus 10 log this. Now L2 minus L1 is already given to us, 20. The loudness reduces by 20 decibels. So this is 20. 10, once again, 10 log. Now use logarithmic rules. Log A minus log B is log A by B. When you divide both of them, think about it. I2 by I minimum divided by I1 by I minimum. What are you going to get? You are just going to get log of I2 by I1, guys. Use definition of logarithms. That's it. 10 log I2 by I1. And that is equal to 20. 0, 0 cancels. So log of I2 by I1 is 2. That means, again use logarithms. I2 by I1 is 10 to the power 2 because the base was 10, guys. The base was 10. So 10 to the power 2 is I2 by I1, which is 100 times. So the ratio of intensity is 100 times. So this is intensity of the loud sound by this is the intensity of that faint sound. That's it. So the intensity reduces 100 times. That was the answer. I hope this is clear. It was not so difficult. Yes. Yes. This is such a simple question. Look at that. 100 times. Yeah? Very good. Very good. Very good. Yes, Ankita, I'll definitely make playlists for optics also. Whatever is not done, I'll just get behind all the backend team. Now this question also many people made mistakes. A window whose area is 2 meters square opens on a street where the street noises come inside with an intensity of 60 decibels. Okay. How much power enters the window via those sound waves and how much energy is collected in 5 hours? How much energy enters through the window and how much energy is collected in 5 hours? Very interesting question. Don't worry about the options, but let's do this, guys. It's not that difficult. Okay. It's not that difficult. See, read the question carefully. I've kept the question in front of you. So all you need to do is think about it this way, that, all right, this is your window, all right, and sound is entering that window like this, okay, and that area is given, that intensity is given, or rather loudness is given. So from loudness, calculate intensity. Loudness is 10 log, loudness is 10 log I divided by I minimum. Loudness is 60 is equal to 10 log I divided by 10 to the power minus 12. 0, 0 goes. So I divided by 10 to the power minus 12 is 10 to the power 6. Therefore, intensity is how much? 10 to the power 6 into 10 to the power minus 12. 10 to the power minus 6 watts per meter square. Check this out. Now, if once intensity is found, rest of the job is simple. The question is, how much power enters the window? How much power enters the window? Power is basically intensity multiplied by area. Intensity, this is per meter square into area. So it is 10 to the power minus 6 multiplied by, how much is the area? 2. So 2, so that will give 2 microwatts. 10 to the power minus 6 is micro. So 2 microwatts is the power, guys. That's the answer for that particular question. And how much energy will be collected in 5 hours? Remember, power is nothing but, what is power? Energy by time is equal to 2 into 10 to the power minus 6 watts, correct? So therefore, the energy collected will be 2 into 10 to the power minus 6, 5 hours. Each hour is 60 minutes and each minute is 60 seconds. Do the math. 2 5s are 10. 60 into 60, 3,600. Into 10, 36,000. 36,000 has how many zeros? Just check that. 3 zeros. Now do that. I think you should get the answer. You should get the answer. Yes. So basically you should get this as 36 into 10 to the power minus 3 joules. That's the answer, guys. That's it. Isn't it? Looks difficult, but it isn't if you solve it carefully. Yes, that's it. So 2 microwatts and 36 into 10 to the power minus 3 joules. Okay, now the last thing that I would like to tell you, just remember this is not a problem. Yes. Now just remember this. Reflection and reflection and transmission of waves. See, if you create a crest and if it goes and hits a wall like structure like this, you will see if that point, okay, is allowed to move, and if it is not allowed to move, depending on that, you will see the reflected sound can be a crest or can be a trough. That's very important. So basically, oops, I think I showed the other part, my bad. So just forget this part. Just forget this part. Imagine there is a wave which comes here from this side, okay, and this point is not allowed to move. You will see a crest will come back as a trough. That's very important. Look at it again. This point is not allowed to move. So if a crest comes from there, and same thing over here, the point is allowed to move. So this is a fixed end, this is a free end. So the crest comes back as a trough. Here the crest goes back as a crest. So this is how reflection occurs at a fixed end or a free end. Very, very important. Very, very important. Clear? Now you can think of it as if, because this point is not allowed to move, okay, think of it for a fixed end as if there was a wave coming from the other side which was exactly opposite of this crest, so that when they meet, this point doesn't move. So that this point, forget this point now, this point doesn't move, as if a trough came from here, so that this part doesn't move, and you will see a trough reflecting back, just to make sure that this point is not moving. And for making this move, think of it as if, because this point is allowed to move, there is a crest which comes from there, and it just reflects back as a crest. That's it. Yes. So remember this. So whenever basically sound is incident, some part gets transmitted, some part gets absorbed, and some part gets reflected. Keep this in mind. What gets transmitted will be the same thing. If a crest comes, the crest will go. Or if a trough comes, the trough will go. But the reflected is always reverse for a rigid end. If it's a rigid end which is not allowed to move, then it will reflect back as the inverse thing. If it is free, then crest will go back as crest, trough will go back as trough. Keep this in mind. Okay, very, very important stuff. Now these are your homework problems. First homework problem. Okay, then answers and solutions are there in the PDF. Second homework problem, again answers are there. Third homework problem, again answers are there. Okay, all of that is there in the link below. And also if you join the Telegram group, you can find the entire PDF with the solutions on our Telegram group. And for all the new members or those members of 12th or dropper students, do not forget to check out the link for all the details of the crash course with live sessions, with doubt solving before and after the class, and also test with discussions which are going to happen in the crash course exclusively for you. The crash course has started today. Do not forget to enroll in it. The usual price being 10,000 has been offered to you at a discounted rate of 8,000 rupees once you use the coupon code SHCC. So do not worry, you have not missed much. Join it today only. Check out all the details. Amazing teachers, amazing teaching. So guys, hit the subscribe button if you are new to this channel, if you have not done it yet. And if you have done it and you have not yet liked the video, please do that right now. Okay, for all the efforts that we take. Thank you guys. See you tomorrow. The timetable is there in the PDF. Check the PDF. Tomorrow we'll be doing electromagnetic waves and light. That's very important. Okay. See you. Bye bye. Take care. Have a great night.